Excellent. Plus, and now we have to be careful because this is a product. And of course, the right-hand side will be 0. So 5 dp over dt, excellent. Plus 4 dx over dt, excellent. So now 2 and p prime. So it's 2 dp over dt multiplied by x, but then plus 2p times dx over dt. Is this okay? Everyone?
Yeah.
Perfect. Okay, so let's ask ourselves now, what am I asked to determine? Dx over dt. So dx over dt is here. And where's my other prop? I lost my other prop. No, I got it. And dx over dt is here.
So move everything else to the other side.
Exactly.
Factor
this goes
dp over dt.
Excellent. Yes. Okay, now you can teach this class and I can relax. Brilliant. Exactly. So the variable is here and here. So we have 4 plus 2p dx over dt. This moves. And this moves. This goes to the other side. This goes to the other side. They were positive, so they become negative. And yes, dx over dt will be all this over this. And of course, it's done. All I need to do now is plug in all those. X equals 3, p equals 5, and dp over dt is 1.5. Okay. P is 5. 2 times 5 is 10, plus 4 is 14. dp is 1.5. Negative 5 times 1.5, negative 7.5. Negative 2 times x is negative 6. And times dp over dt, which is 1.5. Okay, so we get negative 7.5, and this is negative 9. Correct my numbers. I think it's negative 16.5 over 14. Right? So this is negative 9, negative 7.5, negative 16.5 over 14. So we can write it as negative 165, multiply top and bottom. And we can calculate this and see what it is. So 165 divided by 140. Okay, negative 1.2 roughly. So approximately negative 1.2. Okay, now measurement unit. X sales. Time, days.
Sales per day.
Sales per day, excellent. So it's decreasing. Not good. Excellent. Okay, let's see another problem. Let's look at, I don't know what will interest you. Body surface area. Let's look at 43, body surface area. And this one is on page 366. This is it. This is the end of this chapter, and I will, after this problem, I'll show you how we deal with slant asymptotes, because I keep promising. And we'll choose a problem with a slant asymptote, and we'll work on it. And okay, so body surface area. certain chemotherapy dosages depend on a patient's surface area. According to Mosteller model, S, surface area, is the square root height, weight over 60, where H is the patient's height in centimeters. H in centimeters. W is the weight in kilograms. And S is the approximation of the patient's surface area in square meters. Okay, assume that Kim's height is a constant. So the height, this is given to us as a constant, 165 centimeters. But she's losing weight. If she loses 2 kilograms per month, how fast is her surface area decreasing? When she weighs 70 kilograms. Okay, so let's read the question one more time. So we're given the fact that dosage of chemotherapy depend on the patient's surface area. And a lot of effort and time was put in this formula. Surface area, which is a function of time. Height, which is not. There is no assumption that the height changes in any way, shape, or form, although over years height changes, but it's given as fixed. Okay, but weight changes, which is a function of time. Therefore, surface area changes as a function of time. So what is given to us as 2 kilograms per month? What is this? And then we're asked, find how fast is her surface area decreasing. So I make myself a note. I better get a negative at the instant when blah, 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 we don't care. So the first question I have is, what is given here? And what are we asked to find?
Is the first one dW over dt?
Absolutely, of course. dW over dt. How do I know? Kilograms per month. Good. So what are we asked? One more time. If she loses 2 kilograms per month, how fast is her surface area decreasing at the instant blah, blah, blah?
Would that be ds over dt?
Absolutely. Thank you very much. ds over dt. Awesome. Great. Good. So I don't have to come up with any formula. The formula is given to us. Thank goodness. And this is a function of time. And this is a function of time. This is not. This is fixed. So the formula basically is S equals the square root of 165W, everything divided by 60. This is what I should. This number does not follow after when, or at the moment at which, or at the instant, blah, blah, blah. No. This is given to us as a fixed number from the very beginning. It does not follow after the word when. Find this when blah, blah, blah happens. Okay, good. So the left-hand side, when we differentiate to find the rate of change, what do we get?
ds over dt?
Yes, thank you so much. Awesome. Of course, 1/60, you know I'm not going to mess with that. So now we are differentiating this piece. That's a number, can stay outside. 1/60, not 60, right? It's 1/60. Good. How do I differentiate this?
dw over dt.
I have the square root. The square root of a function. Let's not rush. The square root of a function. How do I differentiate the square root of a function?
dw over dt.
Okay, we forgot how to take this, how to differentiate the square root of a function. So the square root of a function prime is 1 over 2, the square root of the function, and then times the function prime. So whatever I have here, the square root prime is 1 over 2 the square root of 165w times the inner function prime. I need to differentiate this now. What do I write?
Is it just 165?
Times.
dw over dt.
Exactly. Great job. Good. So I don't care to do anything else. At this point, I can plug in my numbers. So that final step is ds over dt when w equals 70 and dw over dt is given to us as 2. Okay, what is at the top? I have 165. In the denominator, I have 120. I have the square root of 165 times 70. And times here the dw over dt, which is 2. So I can multiply up here. Okay? Careful, careful, careful how we put this in. The numerator, 165 times 2. Close, divide by, parentheses, 120 times the square root of 165 times 70. I close the inside and then I close the outside. And press enter. 0.025588. Measurement unit, please.
Would it be meters squared a month?
Meters per squared per month. Excellent. Because surface area is given to us in meters squared and time is given to us in months. Excellent. Great job. How do we feel about related rates? Initially, it looked difficult, right? But once you decompose everything step by step, it shouldn't be that hard. How do you feel about it? Would you like to upload just this for me? I think I have the upload created. And then I will show a function with a slant asymptote.
Part of my page cut off because I had to make a new page. Can I just send the second page?
Yes, whatever you have, I'm fine. Yes. Any questions? Any questions for me here? Let me know if you need more time to upload. Is the upload there?
Yeah, it's there.
Should I still wait? Or can I start the slant asymptote on a function?
I'm good.
Anyone else needs time? Needs more time?